A digital system may contain thousands or even millions of records. Buildings, rooms, equipment, people, contracts, work orders, costs, documents. But having many records does not mean that the system understands the built environment. The same room may appear under several codes. The same equipment may exist in several applications. A work activity may be disconnected from the contract that authorized it, may be disconnected from the work that generated it. And a document may exist without a clear relationship to the asset, activity, or responsibility it describes. Data becomes useful only when we understand what each element is, how it is identified, how it relates to other elements, and which rules govern the actions performed upon it. That is the purpose of CAFM Table of Elements and the Bruce dataset. Welcome to the Digital Builder. I am Miguel Sanchez Miguel. On this channel, we explore how business, technology, information, and people come together to shape the built environment of the 21st century. Today, we are going beneath applications and processes to examine the information structure that supports them. In previous strategic discussions, I explained why facility management requires a broader digital model. But every digital model must represent something. So the question for this video is, what are the fundamental operational elements required to represent and manage the built environment? Our answer began with what we call the CAFM Table of Elements. Its canonical structure is called the Bruce dataset. The Bruce dataset is not simply a collection of database tables. It is a shared operational structure for describing the entities, relationships, and transactions of built environment management. The concept was inspired by the logic of the periodic table. The periodic table identifies the fundamental chemical elements from which materials are formed. The analogy is not literal. Buildings and organizations are not chemical compounds, but the principle is useful. Before we construct complex digital processes, we must understand the fundamental elements involved. What are we managing? Who participates? Which commitments govern the work? Which activities are performed? Which resources and costs are involved? Which communications and documents must be preserved? And how are all these elements related? The table of elements gives us a structured vocabulary for representing this operational reality. Before explaining the structure, I want to explain the name. Bruce Kenneth Forbes was the founder of Archibus and a dear friend of mine. His work contributed enormously to the development of computer-aided facility management and to my own professional journey. Bruce passed away in 2016. Using the name Bruce is my personal way of honoring his memory, his work, and the influence he had on my life. The Bruce name now identifies several related concepts and products, but they must not be confused. The Bruce dataset is the common information structure. A Bruce ID identifies an individual element. Bruce smart contracts express govern digital rules. Bruce transactions record accountable interactions. Bruce data governance, also we name it Bruce grid, governs identity, classification, relationships, audit, and evidence. Products such as Bruce BEM, Bruce Platform, and Bruce AI use these concepts, but the concepts are not products themselves. The Bruce dataset is organized into 7 operational areas: stakeholders and collaboration, assets, contracts and service commitments, works and activities, resources, costs and financials, notifications, and documents. These areas describe the principal operational structure through which built environment management takes place. They are not 7 isolated software modules. They are interconnected areas within one universal data structure. The first operational area is stakeholders and collaboration. The built environment is shaped by people and organizations. Owners, investors, operators, occupiers, designers, consultants, contractors, manufacturers, service providers, authorities, and many others. This area describes who participates, their roles, their responsibilities, their organizational relationships, and their involvement in collaborative processes. But the collaboration is not simply a list of contacts. It includes responsibility, communication, approvals, access rights, accountability, and participation in shared transactions. Stakeholders are not outside the data model. They are active elements of the management reality. The second operational area is assets. This area follows a fundamental principle. Every managed place, object, or component is an asset. A campus is an asset. Equipment is an asset, and a part is also an asset. We do not create one rigid structure for locations and another unrelated structure for equipment. We use one universal asset structure. The second principle is equally important. Any asset can contain any other asset, independently of type. A campus may contain sites, a site may contain buildings, a building may contain floors, a floor may contain rooms, a room may contain furnishings and equipment, equipment may contain parts. But this hierarchy is not fixed. In one country, a property may contain a complex. In another organization, a complex may contain several properties. A hospital may organize assets differently from a university. An airport may require another structure. A manufacturing facility may use production logic rather than conventional property logic. The hierarchy adapts to the stakeholders' reality. The stakeholders' reality should not have to adapt to a rigid software hierarchy. This allows unlimited asset structures reflecting country, institution, industry, and organizational idiosyncrasies. The third operational area is contracts and service commitments. A contract does more than identify two companies and a start and end date. It establishes obligations, responsibilities, scope, commercial conditions, performance requirements, service levels, approvals, limitations, and boundaries of accountability. A service commitment may apply to one asset, a group of assets, an organization, a location, a type of activity, a period of time, or a measurable outcome. Contracts and service commitments give operational activities their authorized, commercial, and performance context. But a signed agreement cannot execute itself inside a digital process. This is where Bruce smart contracts become relevant. A Bruce smart contract is a governed digital representation of selected rules contained in or associated with an agreement. It does not replace the signed legal contract, although there is technology inside of Bruce platform. To do it, the legal contract remains the authoritative formal agreement between the parties. The Bruce smart contract operationalizes the parts of that agreement that must be interpreted and executed digitally. For example, which stakeholders may participate, which roles they perform, which assets are covered, which services are authorized, which service level apply, which approvals are required, which conditions trigger an activity, which information may be accessed, which deadlines must be respected, which commercial rules apply, and what happens when a commitment is accepted, rejected, completed, or breached. The legal contract establishes the agreement. The Bruce smart contract translates selected parts of that agreement into machine-readable operational rules, and thanks to technology, enforces legally when using the blockchain concept. Despite the familiar term smart contract, this should not be confused with a speculative cryptocurrency mechanism. Its purpose is practical: to make contractual and governance rules executable across built environment processes. Bruce smart contract may also govern access and role management. An owner may have one set of rights. An operator another, a service provider, another one, an inspector, another, and an occupier, a different one. These rights may depend on the stakeholders' organization, the asset involved, the applicable contract, the current activity, the stage of the workflow, or the responsibility assigned to that participant. Access is therefore not only a technical user account setting. It can be connected to contractual responsibility and operational context. The fourth operational area is works and activities. This includes what people and organizations plan, request, approve, perform, inspect, and complete. Maintenance, inspections, project, tasks, service requests, operational routines, compliance activities, installations, replacements, and many other forms of work. An activity may be initiated manually. It may be scheduled. It may respond to a notification, or it may be triggered because a condition defined in a Bruce smart contract has been satisfied. Every activity should connect to its complete context. Which asset was affected? Which stakeholder requested it? Which stakeholder was responsible? Which contract or commitment authorized it? Which smart contract rules applied? Which resources were used? Which costs were generated? Which notifications were issued? And which documents were involved? The fifth area is resources, costs, and financials. Work requires resources: people, time, materials, tools, equipment, energy, external services, and financial capacity. The model must connect resources and costs to the activities, assets, contracts, and stakeholders that generated or consumed them. A smart contract may also define operational or commercial rules related to authorized rate, budget limit, billable activities, penalties, service credit, or required approval. A cost without context tells us very little. A cost connected to an asset, activity, commitment, stakeholder, and applicable rule becomes management information. The sixth area is notification. Built environment management depends on communication. A problem is reported, a threshold is exceeded, a request is submitted, an approval is required, a deadline is approaching, a commitment is at risk, a transaction changes state. Notifications are not merely emails. They are structured communications connected to relevant assets, activities, commitments, smart contract rules, and stakeholders. A notification may inform, request action, trigger approval, escalate a failure, or record that a contractual condition has been reached. A notification should preserve why it was generated, who received it, and what action was expected. The seventh operational area is documents. Documents may include drawings, manuals, specifications, reports, certificates, contracts, photographs, models, instructions, and other files or structured content. The documents area manages those documents and their relationships to other elements. A manual may relate to an asset. A drawing may relate to a building. A certificate may relate to an inspection. A signed legal agreement may relate to a contract record and to the Bruce smart contract that operationalizes selected terms. But a document is not automatically evidence. That distinction is essential. A document is an information object. It may contain a statement, drawing, signature, photograph, or certificate, but its mere existence does not automatically prove who performed an action, when it occurred, which systems participated, which smart contract rule was applied, whether the action was authorized, or whether the record has remained unchanged. Therefore, we do not rename this operational area documents and evidence. The operational area remains documents. Evidence belongs to the governance structure, specifically to Bruce Data Governance or Bruce Grid. Bruce Grid operates across the complete Bruce dataset. It is not an eighth operational area. It is the governance structure that gives coherence and trust to all 7 areas. Bruce Grid covers identity, classification, relationships, governance, audit, and evidence. It answers questions such as which individual element are we referring to? Who is it classified? Who is it related to other elements? Who is authorized to act? Which smart contract or governance rule applies? What changed? Who performed the change? And what trustworthy record demonstrates that the transaction occurred? The operational areas describe the management reality. Bruce smart contracts govern how selected actions should occur. Bruce Grid governs the identity, relationships, audit, and evidence across that reality. A connected structure needs reliable identity. The word building identifies a type of element, but we also need to know which particular building we mean. The same applies to an asset, stakeholder, contract, smart contract, activity, or document. For this purpose, we use the concept of Bruce ID. A Bruce ID is a universal unique global identifier for an individual element of the Bruce dataset. The Bruce dataset tells us what kind of element it is. The Bruce ID tells us exactly which element it is. This becomes essential when several systems and stakeholders refer to the same operational reality. An asset alone tells us what exists. A relationship tells us what it means in context. The asset is contained within another asset. The asset is owned by a stakeholder. The asset is covered by a contract. A service commitment applies to it. A Bruce smart contract governs selected rules. An activity is performed upon it. Resources are consumed, costs are generated, notifications are issued, documents are connected, and accountable transactions preserve evidence of what occurred. The power of the model does not come from separate lists. It comes from the relationships connecting the entire operational structure. When a governed action occurs, it can be represented as a Bruce transaction. A Bruce transaction records an interaction between identified elements, systems, and stakeholders. For example, a request was submitted, an activity was authorized, an asset was inspected, a service was delivered, an approval was granted, a document was accepted, or a contractual commitment was fulfilled. The contract defines the applicable digital rules and conditions. The Bruce transaction records what actually occurred under those rules. Smart contract, what should happen? Transaction, what did happen. This distinction is fundamental. Through Bruce platform, X-Road Evo, described as blockchain for business, is used to make Bruce transactions accountable, secured, and immutable. The Bruce transaction can therefore serve as evidence. The evidence is not simply a file stored in the documents area, and it is not merely the smart contract rule. The evidence is the governed and auditable record that a specific transaction occurred between identified participants in relation to identified elements under defined authority and rules, an identifiable time with a traceable result. A document may be attached to or referenced by the transaction. A smart contract may define the governing conditions, but the Bruce transaction records the accountable event. Imagine that an air handling unit requires inspection. The legal service agreement defines the formal relationship between the owner and the service provider. The Bruce smart contract expresses the applicable digital rules: which asset is covered, which service provider is responsible, which inspection standard applies, when the inspection is due, who may approve the result, and what happens if the deadline is missed. The technician performs the inspection. The activity is recorded. The relevant document or certificate is attached. The responsible stakeholder accepts the result, and the complete interaction becomes a Bruce transaction. The legal contract establishes the obligation. The smart contract operationalizes the rules. The work activity performs the service. The document contains related information. The Bruce transaction records what occurred, and Bruce grid preserves the audit and evidence. Different systems may use different database structures, different names, different identifiers, different classifications, different workflows, and different representations of contractual rules. But beneath those technical differences, they often describe the same operational reality: the same asset, the same stakeholder, the same contract, the same commitment, the same activity, the same cost, and the same document. The Bruce dataset provides the common semantic structure. Bruce IDs preserve identity. Bruce smart contracts express govern operational rules. Bruce transactions record accountable interactions. And Bruce grid governs relationships, audit, and evidence. This creates the foundation upon which interoperability can become meaningful. Artificial intelligence can analyze text, images, patterns, and transactions, but useful intelligence requires context. A cost without activity has limited meaning. An activity without an asset has limited meaning. A service commitment without an applicable rule has limited meaning. A document without a relationship has limited meaning. And a transaction without identity and governance cannot be trusted. Connected and governed information provides the context artificial intelligence needs. AI does not eliminate the need for structured data, smart contracts, or governance. It increases their value. The Bruce dataset provides 7 interconnected operational areas: stakeholders and collaboration, assets, contracts and service commitments, works and activities, resources, cost and financials, notifications, and documents. Across them, Bruce IDs preserve identity. Bruce smart contracts translate agreements and governance requirements into digital operational rules. Bruce transactions record what actually occurs. And Bruce grid governs classification, relationships, audit, and evidence. Every place, object, and component can be represented through one universal asset structure. Any asset can contain any other asset. Every operational element can maintain a unique identity. And every governed transaction can preserve an accountable record of what actually occurred. The operational areas describe the built environment. The relationships give it meaning. The smart contracts govern its digital actions. The transactions record its events. And Bruce grid makes the result trustworthy. That is the purpose of the Bruce dataset. Once we have a common structure and governed rules, the next challenge is enabling different systems to execute those rules and enabling independent stakeholders to participate in accountable transactions. That is where interoperability, collaboration, Bruce BEM, and Bruce Platform become relevant. I am Miguel Sanchez Miguel, and this is the Digital Builder, navigating the built environment of the 21st century.